Hi, in this video we are going to use identities to solve trigonometric equations. So in the scope of P2 we have two identities, sine x over cosine x is tangent x and sine squared x plus cosine squared x is 1. We are going to employ these identities in trigonometric equations to have them either simplified or clarified a little bit so that we're not going to be missing any solutions. Let's see some examples. Here we are supposed to solve this equation in this interval, right? Now this looks like a quadratic equation. I hope you can see this immediately. So if you'd like, you can just make this conversion and then rewrite this equation like 2a squared minus a minus 1 equals 0 and solve this quadratic equation. But if you don't feel the need to do this conversion, you can directly start solving this quadratic equation as it is seen. All right, it's totally up to you. Now when you solve this equation, you have the factored form to be a minus 1 times 2a plus 1. Hence the solutions are a equals 1 and a equals minus 1 over 2. Now this is the time when you convert them back to trigonometric function cosine theta. So you will say this is going to be cosine theta equals 1, and you will start finding which angles give 1 when you apply cosine to them. So theta is either 0 or 360, right? And as for this, it's going to be cosine theta equals minus 1 over 2, and theta will be 120 degrees. That's what your calculator will give you. Now 120 degrees is here, right? And the same cosine value appears in here too, where you go 120 degrees in the negative direction. So this means you have to now go in this direction, meaning 360 take away 120, so you'll get 240 as an answer. So you also have to include that in your solution. So you have 0, 120, 240 and 360 as a solution to the given equation. Another example. Now this looks rather simple, but still we have this square expression. So yes, we can directly take the square root of both sides, fine, but then it's going to be plus or minus. So I will actually have two equations now, one of which will be sine theta minus 30 equals square root of 1 over 2, and the other will be sine theta minus 30 equals negative square root of 1 over 2. All right? Certainly, you can rewrite the right-hand side to be 1 over root 2 or root 2 over 2 after rationalizing the denominators, right? So the same applies to the other equation. It's going to be sine theta minus 30 will be minus root 2 over 2. So you have to solve these two equations and end up with probably two solutions from each, which would be 75 and 165. You can just solve this yourself and see the answers yourself. And for the other part, the answers will be 345 and 255. So we are going to include these answers in our solution. It is very important that after doing all this work, you should be writing theta equals 75, right? And then 165, then 255, and last 345 as your solution. So it's best if you just clarify or clearly write down your answers at the end of your work, right? This is very important. Let's see an example with the radian measure. Find the values of x in the interval given, satisfying the equation given. Now, when you look at this equation, you sense that it is something about the sine squared x plus cosine squared x equals 1. That's one thing. And second, just because square expressions are around, it may be quadratic. Yeah, actually it is quadratic. We'll see how. Now, if I just convert cosine x into sine x, then I'll have everything in sine x, so I may convert this to a quadratic equation. So let's play with this. So I'll go like 2 times 1 minus sine squared x. Why? Because of this here, right? And I go on plus 9 sine x. I'll take this to the other side, minus 3 sine squared x equals 0. So if I expand this, it's 2 minus 2 sine squared x plus 9 sine x minus 3 sine squared x equals 0. I can simplify these and write minus 5 sine squared x plus 9 sine x plus 2 equals 0, which then I can change the sign. So it's going to be 5 sine squared x minus 9 sine x minus 2 equals 0 by multiplying everything here in this equation by minus 1, right? At this point, again, you can do the conversion and solve this equation as a quadratic. And when you factorize the equation, you get 5a plus 1 and a minus 2 as factors. And if you solve for these factors, you end up with sine x equals minus 1 over 5 and sine x equals 2. Now, at this point, immediately you have to reject this solution because sine x, whatever the angle is, cannot be more than 1. So this is not a solution for us in terms of converting it. As a quadratic equation, it is a solution, but when we convert them to trigonometric function sine, then we cannot accept this solution. So we have to go with this one. And if we do that, we get x to be minus 0.2014 up to 4 significant figures. And then you can see from this diagram in the unit circle that we have another angle here. Now we have to consider this interval starting from minus pi to pi, right? So this means, first of all, I have to consider this angle, right? It is going to be smaller than minus pi, so I will add that value. So it's going to be minus 2.940 up to 4 significant figures, and the original answer here, right? But when you start with the positive axis, pi is up to here. We can't exceed 180 degrees of pi in here, so I can't go like pi plus this or 2 pi minus this because we're not going to be in the interval, all right? So basically, my two solutions will be this value and this value. Now, this is up to 4 significant figures. So according to the question that you're solving, you have to adjust your rounding. Now, you can see that these questions are slightly trickier because first you have to manipulate the given equation by using these two identities. And then you have to figure out which solutions you're going to include or exclude and such. So you have to be extremely careful while solving these equations. But I always say, practice, that's right, makes perfect. So as long as you're solving enough number of questions, you will be all right. Thanks for watching.